Happy Monday. We made it. It is fall, about time. It's October. We'll see how everything goes. Um, Next Monday, I'm probably going to be really slow, but that's okay because we're just doing midterm review. If all goes well, I'll do the marathon this Sunday, and I've not trained very well at all for it. So hopefully I make the distance. You got 6.5 hours, so I should be able to get that done in 6.5 hours, and we'll see. But I'll probably be pretty slow going up the steps and stuff. But it should be a lot of fun. Hopefully the weather's nice. It's no fun to run in the rain. So we're going to cover chapter 8. Let me put that in our assignments here for Zybooks before I forget. We got 7 due tonight. So do chapter 8. You want that one done before the midterm because it is covered on the midterm. Um, Make sure it's in here with no submissions. Yeah, no submissions. Okay, good. And I'll run the other Zybooks probably on Wednesday. I'll get up to date on those there. All right, so we're doing a deeper dive into lists and dictionaries. Actually, a lot of sections here, but it's not too crazy. Don't worry too much about it here. We've done some of it already when we went into it here. So let me fire up a new PyCharm project. That's right, I got the latest and greatest version now too. This one's so much slower though. I'm so sad. Community was so much faster. They don't have a like support for it anymore, so they don't keep releasing new versions of Community. So I guess I could just keep using the old one, but uh, new project. Call this, what is this, week 8, lists and dictionaries. All right. I'm gonna let that think for a minute. So, a couple pieces, looking at other cool things you can do with lists, all the methods of lists. We've done some of these before. We've done append, where we add to it. You can extend one list onto another. It's like appending an entire list, where you can insert at a given index. I think we've looked at insert. We haven't done a whole lot with it here. We've looked at remove. You can remove items from list. You can pop, which removes the last item, or pop by an index, removes a specific index, not by value. If you want particular indexes, you can sort lists and you can reverse lists. I think we might have done sorting. I don't know if we did sorting or not. So this one sorts in place, so it modifies the list. Um, you can get the index of a given item, or you can get the count of a given item inside of a list. So we got a lot of fun options we can do here. So modifying over it here. There's some other examples. Cool. So iterating over a list. When we go through a list, right, the 4 value in list collection is good, but we can't modify our list while we're iterating over it, or bad stuff is going to happen. So let me show you an example of that here real quick. As soon as this finishes updating, this one is so much slower. I don't even have my main yet. Sorry, more time for coffee, I suppose. Click this little pop-up. It excludes from Microsoft Defender. I don't need it to scan all these files here typically because they're mine. Yeah, so it just speeds it. So there's no antivirus checking because every time you run and build, if the files change, Defender wants to scan them. Like, just skip that, please. Not recommended if you use someone else's code, but if you're writing your own code, you're probably not doing bad things, I would hope. No, no, it's actually really difficult to write malware. You gotta really know what you're doing. So, really? Did I not check the create welcome script? All right, whatever. Thought I did. All right, whatever. We got a main PY. So if we have some numbers, right? We make a list of numbers. Just throw out some numbers for me. Throw them in a list. 9. Okay, cool. Actually, I want just integers for a minute here. I'm going to take out the 4.3. So let's say we wanted to remove all the odd numbers here. So for number in numbers, if now we can say if number mod 2 equals 0, or no, sorry, if it's odd, so just number mod 2. If there's a remainder, right? It's not 0 here. I want to call numbers dot remove the number. We're done. Let's print numbers. So this should remove all the odd ones, right? Didn't remove the 9. So if we put this in debug mode and we take a look and watch it while it's running, you're going to see something happen. So removing items from a list while you're looping through it is considered bad form, and it doesn't work the way you expect it to work here. So once this runs here for a second, so we see our numbers list here, right? The first number is 10. Well, let's step over. Nothing happens, right? It's not odd. 6 is not odd. 4 is not odd. 3 is odd. So we're going to remove 3. So we remove 3 from numbers. The next number in the list is 9, but in our loop, 4 numbers from in numbers, there's nothing left. So because 9 shifted into the spot where 3 was, here we remove 3. When we're looping through numbers, it goes to the next value and there's no next value. So because it's shifting the list as we go, you're going to skip values, or you could skip values. So this is real bad here. Let me just stop here. So don't modify lists while looping through them. So what you could do instead then is we want to loop through a copy, right? And we looked at doing the slicing before, so I want to loop through a copy of numbers here with a slice from beginning to end. And I want to remove from the original. So this way I'll get every number in the numbers list because I have a copy of it, and I can go through and remove those numbers from the list here. So now when I'm done, I've successfully removed all the odd numbers because I've looped through a copy. So looping through the copy makes sure we don't skip, right? And there's no way to remove things from that copy because it only really exists number by number by number here as we go. So don't do this way here. And actually, I'll comment that out here to show you it does actually work. It removes all of them here when we loop through the copy. So we've done that one. So other fun things you can do, like find the max, find the min. You have max, you have min, right? But hey, you wanted to find the maximum even number. So assume the first even number is the max one, right? You got some options here. Lots of ways to loop through our lists as we go. Um, find the sum. So all is not very useful. You'll see it occasionally, but everything is not zero. Everything is true. Or anything is true. Anything is not zero here. It's like you're anding everything together or you're ORing everything together. Not particularly useful. Max and min are great. Sum is great. I wish there was an average, but again, we can do the sum divided by the length to calculate our own average or mean, as we say there. All right, so we got that one. So silly things we can do with lists. Those are just practice ones. You can put a list within a list. This is my favorite thing to do. So it starts to get a little bit crazy here. So if I want my values here, so let's call this a board here. Let's make this a list here, and I want to put a space in it here. Space, space, and space. So this I might consider a row, right? And I want a list of lists here. So that'll be my first row, and then I'll do another row here, and I'll do another row here. So you can kind of think of them as rows and columns. It doesn't exactly work like that, but the first item in the list is another list with 3 values, right? And then, so it's a two-dimensional list, right? A list of lists here. Now, really, it really just is one big long list here like this, but it's not as easy for us to visualize. So we like having it like rows and columns, right? So when we look at how do you reference any one of these particular values here, like this value here, it's at the row of index 1, column index 1. So we'd say my board at row 1, at column 1, and then we can assign it, say like an X. Right? We can change this to be an X here, and we can print. Now, if I just print the board, it's going to give me a big long list here. So that's a little bit ugly. So what we'd like to do is we do these my goodness, list comprehensions. It's the one-liners. Most of the time I don't like them, but for this it's pretty nice here. So what we're going to do is we're going to take for row in board, we want, I'm sorry, so for row, we want the string of the row for every row in the board. And what we want to do with that string is we want to take all of those joined together with a new line character. So I'm going to take a new line character, I'm going to call it join, and I'm going to join every string of that board. It looks like nonsense. I've done it a bunch of times before, but essentially we're saying for row and board, turn it into a string, put it together with a new line character, right? So that way I get my nice little output here, and I get a tic-tac-toe looking board here, right? Again, you could do it the other way. We could say for row and board, print the row, and then print a new line, \n, right? Same idea here, right? This would give me the same board. Oops. No, sorry. I want. That's right. I don't need the new line character. Sorry, I just print the row because it already has the new lines, right? At the end of print, I get the new lines. So same idea here. It's a little bit shorter of an output is all here. Joining them together like that versus going this way. I'll leave that one commented out here. Um, so if I have this board here, right, what I want to do is we're going to play tic-tac-toe with a list of lists. This is a nested list here, right? So I'm going to forget this one for a second here. So we're going to print off the board here. And what we want to do here, right, if we think about how tic-tac-toe is played, you play until the game is over, right? So we can say while not game over, given the board, right? Well, okay, I need to write a game over function, right? We'll come back to that. So we'll have a game over function. So we'll define game over given some board here. And for now, we're just going to return false, right? I'll come back and fix this, right? But, we can leave ourselves a to-do, fix me sort of thing. While the game's not over, great. Okay, what do you want to do? Well, we need to tell the player to make a move, right? So we need to make move given the player and the board, right? So, all right, so we need a function for make move. Define make move given the player and the board. And for now, we'll just pass, right? We don't need to do anything. So what to do, we'll come back and finish this one here. We'll just use that pass keyword so it works here, right? Well, it says, okay, I don't know what the player is. So let's start player off as X, right? X can go first, right? So we'll make a move, and then it goes to the next player, right? Again, we can use these silly ternary expressions if you want, but essentially we can say, hey, if player equals X, then player turns to O. Otherwise, oops, sorry, double equal sign. My goodness, I don't know what I'm doing here. Otherwise, player equals X, right? If it's X's turn, it goes to O. If it's not X's turn, now it becomes X's turn, right? Or you can do that as a one-liner if you like, because why not? We like being fancy, right? We can say player equals X if player equals X. No, sorry, player equals O if player X, else, or no, I'm sorry, is it a colon? No, else O. I think that's what it is, right? No, else X. My goodness. If player's X, X, otherwise, I can't talk right now. Oh my goodness, friends. Okay, if player's X, if this is true, we get the thing on the left. Otherwise, we get the thing on the right. This is why I hate these expressions, right? This is just confusing to have to remember how you write these things here. It's much easier to do if else. But we can do it in one line instead of four, right? I don't know. You'll see these a lot in other people's Python code. They love doing it. I hate them, but I have to try and practice them because they're good for me. All right. Do you guys ever watch The Office? I know that show's kind of old and cringy now. Really hard to watch some of the reruns, but Kevin's my favorite character. And he has this one bit here where he decides he's going to start talking in smaller words and shorter words and things that like, why talk big when short good? I don't know. It's like this. Okay. Why type more line when one line good? Okay. It looks ridiculous, and everyone knows it's ridiculous, but we do it anyway. So, all right, player changes. We make a move. If the game's not over, make a move. The game's not over, make a move. The game's not over, make a move. It's about all there is here, right? Okay, well, how do we know if the game is over? Well, either someone won or it's a tie, right? So, okay, let's do that. So let's return is tied, given the board, or has winner, given the board, right? We can take a big problem and break it down into smaller steps. Functional decomposition. You're going to love that technical term. Promise. You got to say it at your Thanksgiving get together and just see what everyone looks like. Just give the crazy looks they give at you. Saying functional decomposition. All right, so is tied, given the board. All right, so the game is tied if there is no winner and there's no spaces, right? So we probably should do the has winner first, maybe. Define has winner, given the board. And then we'll come back to the tie because tied is if there's not a winner and there's not a space. So we can return It's tied if there's not has winner given the board and there are no spaces. And well, how do we know if there's no spaces? Well, let's do this. We'll say for row in board, if there's a space in the row, you're going to return false. If we find a space in any row, can't be tied. Someone can still make a move, right? Not tied. If we've looped through all of the rows and we haven't found a space, then it's tied if there's not a winner. So we're going to return not has winner given the board, right? Because if there's a winner, we can't be tied. But if there's not a winner, we must be tied if there's not a space, right? Okay, so now let's do the has winner. So you can win three ways in tic-tac-toe, right? You can win by row, you can win by column, or you can win by diagonal, right? So let's do that. So let's return has winner by row, given the board, or has winner by column, given the board, or has winner by diagonal, given the board, right? Why not? Let's take a big problem and break it down into smaller problems, right? It's much easier to do one of these at a time. So let's define has winner by row, given the board. All right, so to win by row, all three characters in the row have to be the same, and they can't be a space, right? So we can say for row and board, if the I don't know what row of 0 does not equal a space, and row of 0 equals row of 1, and row of 0 equals row of 2, right? Does the first one match the second one? And does the first one match the third one? And are they not spaces? Right? If I found that, return true. We found a winner at any row. If I've gone through every row and we haven't found a winner, we can return false. No one won by row. Right? Do all three match? Not space. Do all three match? Not space. Do all three match? Not space. Okay? Has winner by column. Winner by column. Given a board here. Again, I don't like globals, and it's a bad habit to start using globals, so we're just going to pass board every time. Right? We're going to pass board around everywhere because the function needs access to the board. Right? We'll look at a better way to do this when we get to classes. We don't have that yet. So we're just going to pass board around. Okay? So by column then, it's for every row at column 0, for every row at column 1, for every row at column 2, do they match? Right? So really we want for column index in column index in range 3 because I want 0, 1, and 2. Right? Or I could go length of the board. It doesn't really matter. I know I'm going to get 1, 2, and 3 here. If my board at 0 at the column index, right? So give me the row. So first row is row 0, second row is row 1, next row is row 2, and then column index is 0, 1, or 2 as I go along here. So for the first row at the first column, for the first time it loops, if it does not equal a space, right? And if that one is equal to column row 1, right? And that one equals column 2 or row 2. Return true. Right? So if the first row column is not a space and it matches the second row and it matches the third row, we have a winner by column. If we didn't do that, I can return false. Right? I didn't find one. Now define has winner by diagonal, given a board here, right? So now this one just has this diagonal and this diagonal, right? So what's the top left? What row is that? Row 0. What column is it? 0. So 0, 0, 1, 1, 2, 2. Or what's one at the top right? Row 0, column 2, 1, 1, row 2, column 0. So I can return. Now, I know 1, 1 is in both of them here. So I'm going to say my board at 1, 1, 1, 1 does not equal a space, right? And then, so this one has to be true, right? And then my board at 0, 0 is equal to board at 1, 1, and board at 2, 2 is equal to board at 1, 1. Right, that's the first diagonal, right? So that one's true, right? Or the other diagonal matches. Let me grab this one here. Gets a little bit long here, so I'm going to put it on this line here, hopefully. So then I want 2, 0, right? And 0, 2, right? Row 2, column 0, row 0, column 2. Let's see, so it doesn't like, I think I need a backslash there. Yep, there we go. And this is just a return, right? It's either true or false. Either one of these matches or they don't. Right, for my has winner by diagonal. So we're making a big problem smaller. You could break this down to the up diagonal and down diagonal if you wanted. Sure. I think this one's probably okay. Again, it's up to you. You can make as many functions as you want here. Sorry, this is or. That's or has winner, right? So we don't need to return false here. So we should be able to figure out if we have a winner or not, right? So now we have to make a move, given a player and a board, okay? So we need to ask him what row and what column, right? So we need to get the row and get the column. So let's go ask for some input. So this is row, or I don't know, move then is equal to an input of a row and column. Or maybe we should say what player's turn it is, right? So let's do a little formatted string here. So player's turn to a row and column. Now, the move then is going to be the row and the column. So I need to split that, right? So we could take, I don't know, row and column are equal to move.split, right? And then we need the integer versions of those, right? So split, if there's a space there, we'll turn it into two different tokens, right? So we're going to split those. So then you can say, hey, if my int of row, sorry, if board at int of row and board at, oh, sorry, int of column does not equal a space, right? That's no good. Enter again, right? Because I want to make sure really while, right? While it's no good here, right? That was taken, print, can't go there, do it again. Eventually, we'll get out of here and I can put that move there. So I'll take the board at the int of the row, at the int of the column, and assign it the move. Or, I'm sorry, assign it the player. Right? That makes the move. Right? We'll put their mark on the board. That player's turn, enter the row or column. Right? Split it, do it again. Split it, do it again. Split it, do it again. Now we might want to make sure it's valid as well. Like, hey, it's not less than 0, not more than 2. But again, we could add in all sorts of checks here if we wanted, but this is probably okay for now. Um, that should be it, right? As long as the game's not over, do it, do it, do it, do it, do it. So we just need a way to print, right? So we got to print every time. So while the game's not over, print here. We'll print. And then when the game is over, right, probably print one last time here. Right? They can probably figure out if they won or lost or tied. It might be nice to say someone won, but again, our functions don't let us know who won. Right? We just are returning true or false. We've got options, I guess, but that's probably fine here. So let's give it a try. Let's see. Not the game is over. Uh-oh, did it not work? Make move. Should have asked for some input here. Printed the board, didn't it? Nope. Okay, so something's not right with our game over then, because it's never running. All right, well, let's see what I did wrong. Let's put it in the debug mode here. So we're going to step into, now that we have our own functions, right, we need the step into my code here. So is the game over? It is tied or has winner. So let's step into that function. So is tied. It's false. It's not tied. So has a winner. Has winner by row. No winner by row. False. Has winner by column. False. Has winner by diagonal. Must have been true. How did the has winner by diagonal be true? I think my ands and ors here are messed up, right? So it's and does not equal space, and that one is true. Oh, all of this here needs to be in parentheses, right? Because I'm using an or. So right now it's and it together, and then this one was true. This last one, then I said or this. So it's this, and then the last thing was ored on top of that, right? I needed it to be this or this, then and it together with this one here. So just a little logic error there. All right, there we go. So X's turn. All right, where should we go? Row and column. 0, 0. All right, I'll be O, so I'll go 1, 1. Where's X going to go? Well, so there's a 0, 1, and 2. 2, 1?
Yeah.
Okay. So I'll go, let's go 2, 0. Where are you going to go? 0, 2. All right, so I got to go 0, 1 to block you. Now where are you going to go? 2, 2. All right, so I got to go 1, 2 to block you, and you have to go row 1, column 0. And we tied. All right, should we try again? So if you can beat me, you get an automatic A in the class.
1, 1.
1, 1. All right, I'll go 0, 0.
2, 0, 1.
I heard a couple different answers. You guys got to work together.
2, 0.
You hear a 2, 0? We all agree 2, 0? 2, 0? Okay, so I have to block you, so I'm going 0, 2. Where are you going?
Let's go 0, 1. 2. Oh, 0, 1.
0, 1?
0, 1.
0, 1. All right, so I have to block you. You should have gone here. All right, so I have to block you, so I go 2, 1. And where do you go? 1, 0. All right, so I have to block you, so I go 1, 2. Right? And then you have to block me. 2, 2. Oh, we tied. No A for you. It's impossible. You guys know that, right?
Well, it's people know how to play, yeah.
Play my kids at tic tac when they were little. They don't play anymore because it's boring, obviously. But I would always tell them, "Hey, I'd give them $100 if they can beat me." And my wife said that was mean because I never let them win.
If there's a chicken you can play at a place called Reptile Garden in South Dakota, and it always gets to go first. And if you look at the little game board that it has, it's like the lights that'll come on, but you can see the outlines of the lights, and there's only tie and lose because the chicken knows how to play, so you can never win.
Yep.
And it'll even sometimes cheat, so you're putting in the money to play it, and sometimes it'll just pack multiple answers because every time it packs an answer, it gets food. So well, let's make it food. It'll just start packing stuff. But yeah, you just can't win.
It's a real chicken?
Top and put in like $10. How do you feed this chicken?
Playing tic tac toe with the chicken.
Yeah.
It's fun. So very exciting stuff. Tic tac toe is a great game, but it's a nested row and column, right? It's a list within a list. Now 0, 0 is the top left, right? We don't get the origins. We're not math land. There's no center, right? Top left is always 0, 0 because it's the first row, the first column. It's a little weird if you use to mathland, right, where you have an origin, but it's okay, right? We'll just pretend it's like that here. Now, if you want to go nuts, you can make a three-dimensional list, a list of lists of lists. And we can pretty much picture a cube in our heads, right? We're pretty good at 3 dimensions. But you can make a list of list of list of list and go to a 4th dimension. And if you like hypercubes, you can imagine that. My head starts to hurt after 3 dimensions, right? But as many lists as you want to put inside of lists, you can put inside of lists. Python doesn't care. It just starts to get stupid at some point because it doesn't make any sense anymore. And the code we write is for us to make sense of it, right? We have to understand what we're writing and make sure that we understand what we're doing. So if you start getting beyond 3 dimensions, we've probably done something wrong. And there's a better way we can represent our data here. But list of lists is pretty common, right? Because we're going to have, here's my rows and here's my columns, right? Not only can you do that with lists, but you can do it with dictionaries. Right? You can make a dictionary of dictionaries. So I can have something like a gradebook here that is a dictionary. And inside of that gradebook, I can have, say, a key with another dictionary as the associated value. So I can take my gradebook, gradebook, key of, we'll say Eric, and then the value I want to associate is another dictionary here. And maybe I have something in here like, how about the, I don't know, test one, right? And the value associated with test one is 100, right? And then maybe I have assignment one, the value associated with that might be 20, right? Something here, right? So I can have a dictionary of dictionaries, right? If you print out gradebook, it prints like you'd expect, right? It doesn't give you one at a time here. Oops, we want to not play tic-tac-toe. Hang on, let me put this at the top here, actually. Put it at the very top. Right, so we get Eric in this. So if we add another entry to the gradebook key of, let's add Jeb to the gradebook here. Jeb, right, let's give him different scores. Let's go like 90 and we'll go 20 on the assignment. It prints out the same, just long here. So if you want it row by row by row, right, we'd have to do the same sort of thing here. We'd have to say, well, for, I don't know what, name in gradebook, print the gradebook key of the name. But really we want like the name and that, right? So now we get, okay, here's Eric's associated dictionary. Here's Jeb's associated dictionary, right? Maybe you even add in the, you can do a formatted string here, right? Do like name and then colon, the gradebook value associated with that. It'll look a little bit nicer here. Or at least you get it on one row, right? So here's the name and the associated value. So you can have a dictionary of dictionaries. So to change a value associated with test one, we'd say, hey, gradebook, key of Eric, then key of test one, change the value to 99, right? So same like row and column, but it's key of and key of because they're dictionaries, right? Here's the key of the inner dictionary. So we get key associated value, key associated value. And you can go level by level by level by level here, right? So now I changed my score to, oops, let me do it before I print, right? So you see my score changed to 99, right? This sort of thing. Just fun. So, and you can mix and match. You can have a list of dictionaries or a dictionary of lists or anything you want here. We can mix and match and have these sort of nested values where it gets pretty crazy here. So when you get to your list nesting, right? List of lists, sure, with rows and columns. That's all what you did here. Um, the slicing, right? Works the same way with a string, right? You can take slices, start and end index. The slice notation is the same way. You can give it the stride, works the same way as well. Pick out different values. Optional bits here, we did the copy. Right? Copy is pretty common. Uh, when you modify the list, right, we wanted to modify loop off of a copy, not the original, right? So you don't skip anything here. Or go by index, right? So if you go by index, you can modify the original. If you're doing the regular loop, you can't copy off of it here. Changing the size, yeah, so adding to it, using the slicing here, right? Go through and do slicing. List comprehensions. Here's that, okay, I did the one-liner here, right? So for something in the loop, you do something with it. You can make a copy of it, essentially, if you want it here, which is nice. So if you give it the square braces, you get a copy of it rather than just doing it as a one-liner. This is pretty common. People love doing these sorts of things here. So this might be actually nicer here. So in our syntax, so I don't have to redo all of our ints here. It'd be nice, I could say, I want a list of, I want the int of the value for value in move split here. This will give me the integer version of whatever they typed in for every token in their move that I split. Right, this is sort of a nicer one-liner. Now I don't have to do the ints here. So I just have a row and column integer value here. Bless you. Does that make sense? So we can use that list comprehension. Right, and then we just have to repeat here. So for value in this, right, do this. So it's taking the part that was in the for loop, right, and putting it in the front. And then it turns it into a list with these square braces here, which is a little bit silly, but sure, we can do it. So that should work fine for tic-tac-toe now. Right, so 1, 1, and it worked out okay, good. So we still get our integer values, right? So let's list comprehensions. And people love doing these sorts of things here with for loops versus doing them this way. right? Turning them into strings, turning them into integers. This is what we did with our split, right? Getting the sum of rows, sum of the row with the smallest sum in the two-dimensional table, the minimum sum of the row. Like, you can do silly stuff with it here. Um, Sorting, right? You have the sort option, and you can also use sorted. So sort will change your list. Sorted will give you a new list. So sorted of numbers gives you a new list back without changing the original, whereas versus sort will change the original. So you just have to know, bless you, which one does which. Um, Based on the key, which is fun. So you can give it different keys. So like you could sort with all lowercase here, which is kind of nice. That way you don't have to like change the versions here. It's, hey, we'll take the lowercase version of all my keys, sorting with the keys or sorting without, right? So it doesn't sort, because usually lowercase letters are bigger than uppercase letters, the way that we store their Unicode values. So if you say, hey, just pretend they're all lowercase, it's a nice little shortcut here. And you can also reverse our command line arguments. So when you start a Python program, you can actually get the sysargs out here, which is kind of fun. And you can pass information in. This is a little bit more advanced, but when we run Python programs, instead of having to like type it in after we hit run, I can pass some information to the program when I go run it. So this sort of thing. So if I'm automating when I run my script, I can pass it different information to automate it different ways, or pass it different things. Hey, I want to look for different values here. It was really fun. We can practice that in labs here. Um, oh my goodness, did we get through 15 sections? Oh no, okay, that was no, dictionaries, right? So when we looked at dictionaries, right, our key and associated value, most people don't use the del keyword, but you can. Right? Usually we use pop, right? I think it was pop. Um, and then you can loop through, see if a key is in a dictionary. Yeah, they even have build out your own gradebook, right? Here's the gradebook. You can do um, other cool methods of dictionaries. You can clear it out. You can get a key. Now, what's nice with get is you can give it a default value so it doesn't crash. So usually with our dictionary, right, if I said, hey, I want the value associated with something. So if I were to say print gradebook key of, we'll say Vivi, if I wanted to look up my daughter here, if it doesn't exist, it's going to crash on me here and I get a key error, right? Key error, it doesn't exist. So if you use get, you can say, hey, this one crashes, key doesn't exist. And we leave that commented here. If we use print gradebook dot get, here's the key of VV, and then I can give it a comma. The associated value is like NA or doesn't exist, or key not found. I don't know, found or whatever other sort of default you want here. Now you get out that default value if it's not found. So it keeps your program from crashing here. Now you could also just look, hey, is VV in the dictionary, right? Is this key existing here? Depends on what we want to do. Maybe I want to create a default dictionary, or hey, I can make some empty ones. You got some options here, but get's kind of nice. Um, you can merge one dictionary with another with update. Right? With a list, you could extend and add another list to it. But with dictionaries, it's going to look for matching keys. And if it doesn't exist, it adds it. If it does exist, the keys from the second dictionary get overwritten on top of the keys from the first one. So we're updating it with the keys from the second. If it doesn't exist, it's an add. If it doesn't exist, it's an update. Yeah, you can pop out a key, and pop is also nice because you can give it a default and it won't crash. So pop will remove and give you back the value associated with that key. This is much more common for taking keys out instead of that del keyword. Um, and then looping over a dictionary, right? Most of the time we loop over for key in dictionary. Um, don't worry too much about this hash thing. We'll get into that next class in CIS 2001. We'll actually build our own hashing here, but it's how dictionaries work really fast, which is cool. So you get items, right? The key and value tuples. You get the keys, just the keys, or you get the values, just the values, right? But they're not really lists. They look like lists. If you want to turn them into a list, you can turn them into a list here, and you can use list to turn them into a list. And then dictionary of dictionaries, right? Hey, this gradebook idea here. Here's the grade, or here's a student ID, or something, right? Get all their information out. Key of here. Doesn't this look fun? So this is what artists and songs or albums, artist and a dictionary of the album that has a list of songs, a year, and whether or not it went platinum. So it's a dictionary of dictionaries of dictionaries. Right? We got three dimensions here. Right? The first one, key is the artist name. The next one is key of album, right? Because then I have a dictionary of albums. And then the third one is a dictionary of songs, year, and platinum status. Justin Bieber went platinum. Good job. Is he still cool? The daughters don't like him anymore. He's old now, I guess.
Can you reference like the outer dictionary and then an inner like part of the dictionary, like if you know what I mean?
So,
Like if you reference Justin Bieber and then his year,
so you say music, key of Justin Bieber, Bieber, and then
and year would it put out in the 2010?
so you'd have to go into the album. So you'd have to get the next level here. So this value associated with Justin Bieber is his dictionary of albums. So if you wanted the year for My World, we could have to go print that out. Or you could get each item here and then go get its year value. Is that what you wanted? Like the year of each one?
Or could you chain them all in one command, I guess?
No, so you'd have to say something like for album,
So you'd have to do like a for loop and have
album.
each part of it.
Yeah, in my music of Justin Bieber, Bieber, right? Then I would want to print my album key of the year, right?
Gotcha. There's no way to bypass the other information if you wanted to skip it.
No, because each one exists there, right? So it is its own dictionary you have to access
Okay.
to go get at those keys here. Uh,
So if you did want to build it such that you wanted to skip those, you'd probably have to do it as a list now.
Could you do like Justin Bieber, key of my world, key of your
yeah, but you'd have to know the album name, or you loop through every single album, right?
Yeah, that's
Because
you could, like do a key of like throughout and then have it.
yeah, so we can say Justin Bieber, key of, and then my world, and then key of year,
Okay.
right? We'll get right to that, but you have to know the album name,
Right,
right?
okay.
Yeah. So this dictionary, this key, this key. Right? So this is the three level. Yeah. Yeah. So we just wanted to print just the year here.
Um,
If we printed, this should give us 2010, right? When we run this one here. It's not very exciting, but it should give us 2010. That's the year associated with Justin Bieber, associated with my world, right? Kind of reading it.
if you just put albums, it's gonna list.
So if we said for album in music of Justin Bieber, we could print the album of year, album key of year, right? This will print then. Now we probably want like the name of it too, right? Oops, sorry, album. I'm sorry,
Would have
just this.
Yeah, if it just been print
Print the
Justin
album,
Bieber key of album key of year.
key of album. So we don't need the key of Justin Bieber again because we've already gotten just his music, right?
Right. Well, we meant in the original one you printed where we got 2010,
Yeah.
been print Justin Bieber, and instead of putting the album's name, if you had done key of album key of year, like left it just in quotes like album.
So album doesn't have a value unless you're looping through it.
Okay, so it's not like year and we're in a multiple thing.
No, so this way we get, I think we should get the same result here with this one, right? Because it's just printing the year and he only has one album, right? But if we switch this to Pink Floyd, now we'll get both years. We'll get 1973 and 79. Oops, uh-oh, Pink Floyd. What happened?
You don't have a colon after the for loop.
Oh my goodness, I deleted my colon. Thank you. Name album, I can't spell. Album. Oh my goodness, whatever. As long as it's misspelled the same. Um, string indexes must be what? Music in Pink Floyd. That's the album.
trying to take the index and not
Oh, it's this one. Sorry. Key of the album. Key of the year. No, that should be the album, right? Oh my goodness. Hang on. What's it doing here? Album. I want the value associated with the key of album. My goodness. Yeah, music of Pink Floyd. Nested dictionaries are obnoxious. Key of the album. Aluminum. Oh my goodness. Can't. Key of the year. So because album is the name here, this was the key, right? I got the, because I wanted the, for each key in this one when we loop through, right? This gives me a dictionary that gives me just the key name here. So here's the key name of the dictionary of this one. Nested dictionaries are silly. There, now we get the years out. Very exciting. Right, if we wanted like all of the details, right, we could pick for artist, bless you, in my music. We could print the artist, and then that's their name, and then for, oh my goodness, artist, thank you. For the artist in, oh no, we want for album, um, in music, key of the artist. You can print the album, which is the name, right? Album here. And then for the, I don't know what, detail or something in music, key of the artist, key of the album, we could print the detail and the value associated with that detail. So we get, here's the artist, here's the album, here's the value associated with that one, right? So like we nest for each level because there's each one is another dictionary. Yeah.
Is there an easier way to? I think it's
I mean, most of the time you don't need to print all of it. It's like you're only going to use certain levels as you go. Um, so like you listing it all out is not all that exciting all the time. But they're like, hey, give me all the details about this album. We're going to go through, find that artist, look for an album that matches, and print out the details. That sort of thing. Um, yeah, I think yeah, 3 levels. You can add artists and albums and songs. You have to add the artist, then you have to add the album and add the song. Make sure it checks, see if that album exists before you add a song, right? You can add in some other check. We'll do this with like a great book example.
Let's only have one album. Couldn't you just have it print like everything at once without having to like segment it all like that?
Uh,
Like if you've only got one album, then you just wanted to print everything associated with that artist, and you just have it print everything associated with the artist and like
yeah,
like one man.
it would give you like this version here, right? Like it would look kind of like a dictionary if you just print the
Gotcha. So
dictionary.
you print out less clean.
Yeah,
Saying okay.
yeah. So this looks maybe a little bit nicer, maybe. So yeah. So nesting dictionaries inside of dictionaries gets a little messy. We'll do it for our lab with a grade book. Practice that because it gets to be lots of fun. Um, fun in quotes there, right? Depends on how much fun you want to call it here. I don't actually have much more. That's pretty cool. We did pretty good because we've done these before. It's just looking at a little further versions of these here. Hmm. Yeah, I think we're in pretty good shape. Do you want to? Let's do like a 2D list lab, and then we'll do a 2D dictionary lab next time because we for next week our midterm review. There's no new content. That way we can break our lab up. So we'll do the first lab on 2D lists, and we'll do the next lab next week on 2D dictionaries. That way we don't have too much to do this week. Is that okay?
Sure.
All right, cool. We'll break that up a little bit, and then we can still have lab on 1020 as well. That should go pretty well. All right. Um, yeah. What do you want to do Wednesday then? You just skip Wednesday? All right. You gonna have project time for Wednesday? I don't have anything more to cover. We don't really need to pull stuff early because we still got the midterm coming up. So, just plan to meet next Monday then. Okay, cool. Let's plan for that then. We'll just meet next Monday, midterm review. I'll post the midterm, last year's midterm for you, so you can review that. Ideally, you try it ahead of time, right? And then I'll go over the answers on 1020. It'll be pretty short on 1020, and then we'll do our two-dimensional dictionaries lab on 1020. So we'll do our little grade book example on 1020, okay?
You said the midterm day is not. We're not actually in class. It's just.
It'll open on 1022 and it'll be due 1027.
Okay.
So if you'd like me to sit and watch you take it, please let me know. I'll come watch you take it. But it's untimed. You can have 10 hours on it if you really want 10 hours. You should be able to get it done in an hour. Should. If you need more time, take more time on it. That's perfectly fine. I'm not going to put a time limit on it in Canvas because that's obnoxious.
Let you put out.
Yep.
Okay.
Yep.
Same.
Mhm. Yeah. And so, yeah, I'll post. I can actually do that right now. So before I forget, I think I'll grab last year's info one, fall 2024 quiz midterm preview. Where's the preview button? Preview. There's the button. Why is it so slow? Okay. Yeah. All right. You get 1 point just for acknowledging the academic integrity policy, saying you won't cheat. And interestingly enough, did I tell you this story before? Someone did a research study and they found asking before you start the test, students are less likely to cheat than if you ask at the end of the test. Because by the end of the test, if they've already cheated, they're like, oh, I guess I'm just going to lie. But if they say it beforehand, they're less likely to cheat because they're like, hey, I agreed not to. And then another fun fact, just because it was really interesting, we've got like a big rivalry with Ohio State for some reason. I'm not much of a sports ball person, but sure. So what they did is they brought a bunch of people in from one university, and they had plants set up as another university, like wearing their gear. And the test was like, hey, answer 20 math questions that are relatively hard. When you're done, bring it up front and score yourself. Tell me how many you got right, and you get $1 per right answer. So like after like 3 minutes, someone in say Ohio State got up and went up to the front and was like, hey, I got 20 out of 20. They're like, okay, here you go. Here's your $20. If someone from Ohio State did that, all the U of M fans were less likely to cheat because they're like, of course, dirty Ohio State would cheat. We're better than that. So sort of fun human behavior. But they did another version of that where no one was wearing any sort of swag. They saw someone cheat and they're like, oh, you can cheat and get away with it. As long as it's not my rival, you're more likely to cheat if you see someone else cheat. But if it's your rival, who of course they're dirty, nasty cheaters, and no one likes Ohio, better than that, you're less likely to cheat. So human behavior is just super odd, like that. Um,
Some of the Ivy League schools, they don't. I think they don't do grading and stuff. They follow that whole no cheating policy. Like for every exam, they have you do that same thing where they got the question where you say like I'm not going to cheat,
mm. And you appeal to their nature.
Yale doesn't understand for one of those two.
Yeah, I'm not particularly sure. I don't know, but that sort of stuff is interesting. So first question is that, and then there's some true false. Now, when I say true false, it's if it's false, you have to give me a true statement. You don't just say false. So variable names can be anything you want them to be. Is this true or false?
What's false?
This one's false. So what would be a true statement?
They can't contain numbers.
So variable names can't start with numbers is a true statement then, right? Sure. So you'd have to change it to a true statement. Now, technically, you could say cannot be anything you want them to be, and that would be true, but that's not in the spirit of correcting the statement here, right?
So if we're able to correctly identify whether it's true or false, and we're able to give some information.
As long as the statement's true, you get the point. Yep. So you fix it to be a true statement. So things like that. So other things, like a fill in the blank. Blank is the command used to get input from the user. These are not hard questions, I promise. A function may only return a single value.
Yeah.
Technically true, right? Even if it's a tuple, it's a single value because a tuple is one thing. So yes, this is technically. If you said false, you can return a tuple, which is technically more than one thing. I'd also give you points. I just want to, that one's pretty easy. This is like write some quick code. Write code that will update each value in the list to be 2 times its original value, either with a loop, comprehension, whatever you want to do here. So it's quick little questions here, these sorts of things. There's about 15 of those here, right? So 15 quick questions. These should be about a minute each, right? That is how I'm estimating it here. And then 3 long answer questions. So you're writing a program, enter some values, ensure the values are between a certain range, count how many odd values are entered, print the number of odds after all 10 values are entered. So like, here's a quick little thing. Again, I'm estimating this takes 5 to 10 minutes. If you need twice as much time, you'd still be able to get all this done within the hour or so. So quick little loop with some validation, right? So you'll have a question on a validation loop, and then you do something with those values.
We write that in like PyCharm.
Please, yeah, copy paste it in. So don't write code in this box here. Copy paste from PyCharm and run your code. Make sure it works, right? You have access to PyCharm. Please use it. Um, So another one, write a function that accepts an integer value, counts how many steps it takes to get to a negative value. For each step, subtract the step number from the value. Print the number of steps for the final value at the end. For example, if you pass the value 7, step 1 would change the value 7 minus 1, 6 minus 2, 4 minus 3, 1 minus 4. The last value is minus 3, right? The first step, you subtracted 1. The second step, you subtracted 2. The third step, you subtracted 3. The next step, you subtracted 4. On and on. Eventually, you'll get to a negative number here. So count how many steps and what is the final result. So again, 5 to 10 minutes for this question is sort of the goal. Yeah.
Yeah, I'm sorry. I'm just confused on how you want us to like. What are we copying and pasting into the text box?
Write your code in PyCharm
Yeah.
and then come over here and come back and paste it in.
Paste the code.
Yes.
Okay, yeah, because I thought you meant only paste the print like from.
No, I'm sorry. Yeah, the code.
Bottom. I'm like,
yeah.
Then how are you gonna see? Like,
yeah, no, your code. Yeah. Give me the code. Yep. Yeah, that's all. And then, so we'll have a question on some sort of validation loop, question on functions, and then the last question here. This is sort of some sort of list and dictionary question. Okay, we just did lists and dictionaries. So I'm going to rewrite these ones. Not that you folks would do it, but occasionally people post these things to nasty sites like Chegg and Course Hero, which is a violation of the academic integrity policy. And if I find out that you posted it, you fail the class. So please don't do that sort of stuff. But again, that's what it is. So you'll ask them to loop, enter the name of a class, use that as the key for the dictionary. If it exists, print the list of assignments for the class. They can add more assignments to the list. If they don't exist, create a list with a entry with an empty list, allow them to enter assignments. When they're done, print each class with the associated list of assignments. So it's a dictionary with an associated value of a list. Yeah.
It's probably the question, like, you don't want us to do anything on GitHub.
Yeah, no need to put it in GitHub if you don't want to. If you'd like to put it in GitHub, go for it. But you can just copy paste the code here. It's probably easier. Yeah.
So only the code. We're not printing the actual like. Print.
No, I just need your answers. Just your code solution. Yep. Yep. So 3 long answer questions, again, 5-10 minutes each, so that if it took you double, you'd still be able to get it done on time. That's sort of the idea here. No. You should be able to get it done in a sitting, but have as much time as you'd like on it here. That's perfectly fine. Again, the goal is this is easy. If it's not easy, you and I need to have a conversation and figure out what's not clicking with Python. Right? This is shorter than our labs, right? So this should be pretty easy and doable. Is the idea with this one here, right? So let me. I think I can print this. Let me. If I grab all that and hit print, I think that works. There's a print to PDF. Okay, it's really long because they're all long answer, but yeah. So it looks 12, 11 pages, but it's like you saw, it's not super long here. So we'll do this as CIS 1501 practice midterm. Look at that, practice midterm 2, I guess. I have never cleaned out my downloads folder, sorry. And I'll drop that here. Probably should clean out downloads at some point here. No, come on, Canvas. I swear I know how to work Canvas. That's my files. I want to add a new file. Usually the oh, my goodness. I'm dying here. I'm dying. This old files page. Yeah, give me the old files page. It does. Freaking add a file.
Otherwise, I would see the download.
This will download files. I want to add a new file. That's gives me per class. All right, I can upload. Sure. Go to this one here. Upload here. All right, sure. Thank you. I'll go back to class files. Hey, it's there. Okay. All right, so I'm going to post an announcement. No class Canvas is just being done. Where's my new button? All right, I think Canvas is screwing up for me right now. What happened here? I should have a new announcement button. I'm in the wrong course. That's why. I was in the wrong course, guys. Oh, user error. Okay, we got the pretest. No, practice midterm 2. Okay, yeah. This, if I was in the right class, it would have worked. Okay, not embarrassing at all. Totally. Okay, that's fine. Add a new announcement. Uh, no class. 10:15. Use review sample midterm, and then insert a link to a course link, course file, course files. All right. No class on Wednesday. Take the time, catch up, work on the project, whatever you need to do. We'll meet next Monday for midterm review. That's pretty quick. I'm just going to go over the answers to it. And then we'll do our lab on 2D dictionaries. Okay. Awesome. Sounds good. I'll see you folks in half an hour for lab. We'll do our 2D lists. It'll be fun. You guys like games, right?
Of course.
Connect 4?
I was actually thinking about this.
We'll do Connect 4.